4 into t times t squared. T times this minus 2t. Then t times this plus t. This times this minus 2 minus 4 equals to 0. Then we have t minus 4 into t squared minus t minus 6 equals to 0. So we can solve this one quadratically. So we have t squared minus 3t plus 2t minus 6 equals to 0. Meanwhile, you have t minus 4 here. So here you have t minus 4. In a complex, then you have t squared minus 3t. Then you have plus 2t minus 6 equals to 0. So you have t minus 4. And this one will be t is common here, t into t minus 3. Plus 2 is common here, t minus 3 equals to 0. So we have our t minus 4. And this one will be complex bracket t into. So what is common here? T minus 3. So t minus 3. And this one will be left with t plus 2 equals to 0, which implies that we equate this one to 0. We equate t minus 4 equals to 0, our t equals to 4. T minus 3 equals to 0, our t equals to 3. T plus 2 equals to 0, our t equals to minus 2. So our t equals to minus 2, 3, and 4. So now, question 5. You are given a table. The questioner asks that the identity element with respect to the multiplication shown in the table is. What do you really know about identity matrix? Or I said, what do you know about identity element? Rather, you have A asterisk E is the same thing as E asterisk A, which is equals to A for all A belonging to what? Set of a real number. So in that situation, what we are trying to say is that if you look at the table closely, k times m is the same thing as m times k, which gives k. K times m, k. M times k, k. So also, L times m, L times m is equals to m times L, which is also L. L times m, L. M times L, M times L, L. So that is to show that now m times m, m times m is also m. So in this situation, what we can deduce from here is that m is the identity. Since when you multiply k by m, you are getting k. You are multiplying m by k, you are getting k. L by m, you are still getting L. M by m, you are still getting m. So automatically that justifies the claim that m is an identity matrix. So we go to our option and identify our identity element, rather not identity matrix, identity element. So our identity element here will definitely be m. The next question, once you see a slash like this, a vertical line is on both or both sides of this operation of an operation, it is the determinant. I've said it times without number. So in this situation, we have minus 1, minus 1, minus 1, 3, 1, minus 1, 1, 2, 1. Then I said if you have to look for the determinant of a 3 by 3 matrix, all you need to do is to allocate plus, minus, plus, just distribute them. Then pick the first one. That's plus times minus, minus. Minus 1, you close this and close this. You'll be left with 1, 2, minus 1, 1. Pick this one, minus times minus plus 1. Close this and close this. You have 3, 1. Close this and close, you have minus 1. Then the next one, plus times minus, minus 1. Close this, you have 3, 1, 1, 2. Now, the next thing now is to simplify. 1 times 1, 1, minus 2 times 1, minus 2, plus 1, 3 times 1, 3, minus 1 times minus 1, minus 1, minus 1, 3 times 2, 6, minus 1 times 1, 1. You have minus 1 into 1 plus 2 plus 1 into 3 plus 1 minus 1 into what? 5. This one will give us 3, 1 plus 2, 3 times this minus 3. 3 plus 1, 4, 4 times this plus 4. This one is minus 5. So you have minus 3, minus 5, minus 6. Minus 8 plus 4, that's minus 4. So the answer here will be minus 4. And that is option A. The next question says that given the matrix K to be this, the matrix K squared plus K plus 1 plus L, this is not 1, this is L, where L is, where I, sorry, this is I, not L, where I is 2 by 2 identity matrix. So in this situation, we have to resolve this. That's K squared plus K plus I. In this situation, what is our K? Our K is equals to 2, 1, 3, 4. So if you want to resolve our K squared is the same thing as K times K. Then if you are doing it under matrix, row times column. So in this situation, we have them repeatedly. Now row, this is your row, this is your column. So 2 times, we use our row to multiply our column. 2 times 2, 4. 1 times 3, 3. So 4 plus 3 is what we're going to have here. In this other case, we have 2 times 1, 2. 1 times 4, 4. We have it here. 3 times 2, 6. 4 times 3, 12. Then we have the last one. 3 times 1, 3. 4 times 4, 16. So that means our K square will now be, we had them up. 4 plus 3, 7. 2 plus 4, 6. 8 plus 12, 18. 3 plus 16, 19. So that's what we have for our K square. Then K plus K, K square plus K will now be 7, 6, 18, 19. Plus, what is our K? 2, 1, 3, 4. That will be 7 plus 2, 9. 6 plus 1, 7. 18 plus 3, 21. 19 plus 4, 23. So now, we are now moving to K squared plus K plus I, which is now 9, 7, 2, 1, 23. Addition to our unit metric, which is 0, 1, 0, 0, 1. Now, 9 plus 1, 10. 7 plus 0, 7. 21 plus 0, 21. 23 plus 1, 24. So we go to our option and pick the one that correlates with this, and that is option C, which is 10, 7 to 21, 24. Question 8 is similar to question 7, so it's still the same trend. We have our P to be equals to 2, 1 minus 3, 0. So I'm going to resolve P squared minus 2P plus 4I. Let's solve them one by one. P squared. P squared is P times P. And what is P? P is 2, 1 minus 3, 0. Multiply by another 2, 1 minus 3, 0. So row times column. We have 2 times 2, 4. 1 times minus 3, minus 3. 2 times 1, 2. 1 times 0 plus 0. Minus 3 times 2 minus 6. 0 times minus 3 plus 0. Then minus 3 times 1 minus 3. 0 times 0 plus 0. So, and that means our p squared will now be equals to 1, 2, minus 6, minus 3. I'll resolve that. Then let me talk about 2p. Since my 2p will be 2 into 2, 1, minus 3, 0, which will now be equals to 2 times 2, 4. 2 times 1, 2. 2 times this, minus 6. 2 times this, 0. So this is my 2p. Then my 4i. My I is unit metric, which is 1, 0, 0, 1. So I have 4 times 1, 4. 4 times 0, 0. 4 times 0, 0. 4 times 1, 4. So let me now resolve them one by one. Let me do p squared. I want to solve p squared minus 2p first. So I have, what is my p squared? My p squared is 1, 2, minus 6, minus 3, minus 2p. Where's my 2p? My 2p is 4, 2, minus 6, 0. So this one will be minus 1 minus 4. That's minus 3. 2 minus 2, 0. Minus 6 minus 6. Minus times minus plus, then that becomes 0. Minus 3 minus 0, minus 3. So now to evaluate p squared minus 2p plus 4i. So I have solved for p squared minus 2p.